Hi everyone, welcome to this video. Today we're going to have a look at chapter 6.3. So this is on the circle. So what I've got is a set of axes and I've drawn a circle. Pretty straightforward. Let's say it has a radius of 2. Okay, I'm going to start with that. Now I'm going to go backwards, and instead of just giving you the equation, I'll kind of go through how we can actually work it out. So we've got a center at the origin, so 0, 0, and we've got a radius of 2. Now I can pick any point on the circle, so let's say this point up here. Okay, and that distance there is going to be 2. Well, what's the x and y coordinates? That's what we're going to have a look at. So I can actually make a triangle. Okay, and what distance is that? And what distance is that? Okay, well, I'm going to say that this angle in here is going to be 45, just so it's easy to work with. Okay, so I've picked this point up here, and it's exactly 45 degrees from the origin. Now, using our trigonometry, we'll work out the y value first. So opposite over hypotenuse, so we're looking at sine. So we can say sine 45 is our opposite, which we don't know, over our hypotenuse, which is actually 2. Okay, just remembering our SOHCAHTOA. Alright, so, well, what's y? If we use, so sine 45, sine 45 is, okay, root 2 on 2 using our exact triangles. I'm not going to go through that at this stage. We'll revisit that at a later time. So sine 45 root 2 on 2 equals y on 2, just rearranging it, multiplying by 2 on both sides, we get y equal to the square root of 2. Now we should actually get the same answer for x, so this time we'll be using cos 45, and that's x on 2. Same answer, cos 45 is root 2 on 2. X is going to be therefore the square root of 2 as well. Okay, so how do either of these two numbers have anything to do with circles? Well, we want to work out what the equation is of the circle. Now, just imagine we didn't know what that radius was, but we knew this length was root 2, this length was root 2 as well. So, putting them together, okay, we've got a triangle, and we can use Pythag to work out what r is. So, this length here, which is my x, okay, and we're going to square it, plus our y, and square it. That'll give us our radius squared. Okay, in this case we've got square root of 2 and square root of 2. When we square them and add them together, alright, going to cancel, we're going to get 4. So r squared is going to be 4, so therefore we can say r is going to be the square root of that, which is going to be 2. Okay, so that's how they relate to each other. And I could do the same thing for sine of 30 or 28 or whatever I want and work out the two x and y values, and I'm going to get the same radius. Okay, because we've got a circle, it doesn't change, it's going to have the same radius. So from here, we want to develop a formula. Well, we've actually just developed it here. So a formula for a circle, standard circle, is going to be x squared plus y squared equals r squared. Okay, just exploring that. Let's say we had a circle with radius of, we'll say 9. So we've got radius equals 9. Okay, what's our equation? Well, it's going to be x squared plus y squared equals 81. Okay, and putting that into a graph. Okay, at this stage we're not moving it left or right or up and down. Okay, just going to have a circle. Okay, at 0, 0 is our center, and from there it's going to be a radius of 9. Okay, basically take this number and take the square root of it. So I'm going to have a 9 at this x-intercept, a minus 9 over here, positive 9, negative 9. Okay, and there's my 4 points. So equation for a circle, to start with, we've got x squared plus y squared equals r squared. And generally, you'll be given something that looks like this. Okay, so I said we've got a radius of 9. Why is that? Because the square root of 81 is 9. I could have given you x squared plus y squared equals 16. Okay, obviously the square root of 16 is going to be 4, so the radius will therefore be 4. So that's a standard circle. Now what we're going to have a look at is when we move it up and down, or left and right. So got a set of axes, x and y, and I've got a circle up here. Alright, this center here, and I'm going to pick a point over here. So C and P are there. So first thing is to determine what the distance between the C and P are. Well, obviously that's going to be our radius. So working out this distance here. Well, it actually turns out that okay, how far have we moved across? It's going to be x, and we've moved, let's keep it like our turning point form. We'll x take h, negative meaning we go in this direction. Okay, so it's going to be that distance, and same thing for this one. So we've got y, and we're going to take k. And remember, we've got x squared plus y squared equals r squared. Well, we've actually shifted it to the left, to the right, shifted it up, and there's my squares. Okay, so what is going to be that distance here? That's my radius, which is the distance from C to P. And that's going to be squared as well. In this case, that's going to be r. Okay, just getting r by itself, we're going to get the square root of all that, whatever number they are. And there's my r. Okay, so what we actually get is a very similar case to our turning point form. So here's a standard equation for a circle. Now when we move it left and right, up or down, we're actually going to get x minus h squared plus y minus k squared equals our r squared. So my center is at h and k. Okay, and radius is going to be, our radius is this number, or the square root of that number. Before I go on, we also want to note that a circle is obviously not a function because it fails the vertical line test. Okay, if I draw a vertical line, it's going to touch it twice. But if we also have a look at the horizontal line, it's going to be a many-to-many function, relation, sorry. Many-to-many relation. Okay, so we've got our general equation for a circle. x minus h squared plus y minus k squared equals r squared. Now just going to have a look at what happens when we expand this function. So x minus h squared, let's expand that. So it'll be x minus h, we'll get x squared minus 2xh plus h squared. And similar thing for here, we'll have a y squared minus 2y or 2ky plus k squared equals r squared. And if we take that r squared on the other side, and we'll actually get all that minus r squared equals 0. Now, here we have a very ugly formula now. We started with something nice, something horrible, but we've got to look at this sometimes. And so remembering our general equation as we can say x squared plus y squared plus ax, coefficient of what's in front of x, plus by, so using our a, b's and c's, so b is going to be this one, plus a constant, which is going to be the h squared and the k squared, and that's all equal to 0. So just bear with me for this in a moment. So we've got x squared, y squared, ax, by plus c. Equating these, I can say a is going to be the coefficient in front of x, so it's going to be minus 2h. B is the coefficient in front of y, which is in this case minus 2k, and our constant c is going to be h squared plus k squared, take away r squared. Okay, so 3 bits of information. You've got A, B and C. So this shows that 3 pieces of information are needed to calculate A, B and C in order to determine an equation. So sometimes we'll be given something that looks horribly ugly like this, and we want to put it back into something that looks like this so we can draw our circle. And to do that, we need 3 bits of information. We need H, K and R, or A, B and C. So the general form is converted into standard center radius form. So this is center radius form by completing the squares for both on the x and the y terms. Don't worry too much about that. Let's jump into an example so it kind of makes a bit more sense. So at the moment we're just looking at general equations.